right, everyone? Hello? Sorry, we're going to start the next talk. All right, so I'm Ismael. I'm product manager for Argent. We develop smart contract wallets, and we work very closely with Starkware and developing Starknet. And today I'm going to talk about Starknet, why we're building on top of it, and hopefully convince you to also come to the ecosystem. So yeah, as we all know, Ethereum has a scalability issue, and Starknet is solving that. So as we know, transactions on Ethereum can become quite expensive due to transaction fees, and that's because the network can't really handle that many transactions per second. And that's really due to the fact that for a block to be included in the network, the block producer has to execute all the transactions, and then in order to validate those transactions, all the validators have to execute all the transactions again, and that's a lot of execution resources. But do we really need to execute all the transactions in order to validate them? If we go back to, well, enter Starks. Starks is a cryptographic proof system developed or invented by the founders of Starkware. They did so in 2018. And basically what a cryptographic proof system, or specifically Starks, allow you to do is for a prover to execute some computation and generate a proof of that computation, and give it to a validator, and the validator will just execute that proof and be certain that the execution was done correctly without having to spend all those resources executing every transaction. So in practice, well, going back to the slides from earlier, we see that a block producer has to spend a bunch of resources to execute all the transactions in a block. And then each one of the validators has to spend the same exact resources to validate them. But in a system where Starks are used, a block producer generates or computes all those transactions, and on top of that generates a proof of that computation and shares that proof with all the validators. All the validators, in the end, they just need to spend little resources for proving that proof, and they can be certain that all the transactions are valid. So you can think of these validity proofs as a compression for files. So yeah, validity proofs are to a computation what zip compression is to file size. And this leads to quite efficient systems, because the block producer, in order to add transactions to a block, the more transactions they add, the more resources they spend, and that grows linearly. But for validators, the proof actually grows well, in a polylogarithmic way. So the more transactions that are included in a block, the more efficient the whole system becomes. Now, systems that are already using Starks in production, StarkX is an app-specific rollup engine developed by Starkware, sorry, launched in June 2020, and it's the engine that runs Immutable, Sorare, and DYDX, and all other systems that allow for many transactions to be executed as a rollup on Ethereum, and in a very cheap way. So far, there's been more than 400 million transactions in StarkX systems, and in all of them combined, there's currently more than $500 million in total value locked. Now, Starknet is a validity rollup on Ethereum powered by Starks. And what that means is that it's fully open and programmable. You can program smart contracts on it, same as you can do on Ethereum. And the transactions are way cheaper. We launched the alpha mainnet in November 2021, and we are still developing improvements for it. So we have the scalability issue solved, but we have another big issue in the blockchain ecosystem, which is user experience. And let's take a step back and take a look at this statement. I guess everyone agrees with it now. Self-custody matters, but unfortunately, a lot of the services that we use today are not completely self-custodial. So that's why we still use services like Coinbase or Kraken or Binance are considered non-custodial because they really have control over your assets. And could you really say that you own your asset if you don't have self-custody over it? Unfortunately, in the past year, we've seen all these scandals happening from these services because, of course, if they can have the ability to move your assets, they can do whatever they want with them. And at the end of the day, it can lead to disasters like we've seen in the past months. But why do people keep using those services? It's really because self-custody is really hard. And we can see that every day on Twitter. We see countless cases of people getting either scammed or not knowing what exactly or how to exactly use their seed phrase or store them, and use the wallets that we provide them today. And that's really because of the way Ethereum accounts work. So taking a step back, let's recap what the two types of accounts are on Ethereum. So there's what is called an externally owned account, or EOA, which is the one that holds the user's assets, and then contract accounts, which are controlled by their code. An EOA account has an address for identification and nonce to make sure that transactions are executed in a queue, and a balance in ETH to pay the fees. And a user owns their EOA through a pair of cryptographic keys, or the signer. And the signer and the account are tightly coupled. So the address of the account is derived from the public key of the signer, and transactions for that account can only be signed by that private key of that signer. The signature scheme on Ethereum is ECDSA on a certain elliptic curve, and that's completely hard-coded. That can't be changed. So if we take a look a bit at this representation, on the user side of things, we have the signer with a private and public key. And on the blockchain, we have the Ethereum account, which has the address, the nonce and balance, as we talked. And all of this is hard-coded. The concept of a signer, which is the entity that is authorized to spend your tokens or execute actions, is the same one that holds your assets, and that can't be changed. That's what we call the original sin, and that means that's where all the issues come from. Because if you lose your signer, that means that you lose access to your account. And also, if your signer is compromised or gets hacked, if I have your signer, it means that I have complete access to your account. So the entire security of the EOAs really relies on users managing a single secret private key. And we all know that humans are not great at doing that. There's no safety net. Users can't make mistakes. And this is really a flawed design that won't work for mainstream adoption. Now, can we do better? So in our opinion, layer 2's such as Starknet, are the perfect opportunity to fix some of the limitations of Ethereum. And yeah, enter the concept of account abstraction or smart contract wallets. The goal of account abstraction is to decouple the relation between account and a signer. So in practice, what this means is that an account is a smart contract on-chain that can have arbitrary logic for how to validate the actions that the user wants to perform. So you could imagine having a different signature scheme, a different elliptic curve, or even have multiple signers that are required to sign an action in order to perform it on-chain. And we can have complex logic for modifying the signer of an account. Yeah, and taking a look a bit at the overall architecture, we usually have a wallet, which is a piece of software that the user uses that is in charge of managing the key. Then the user signs a transaction, and that goes on-chain, goes to the Starknet VM, takes that transaction, executes it through that user account contract, and that contract has that validate and execute logic to validate and then later on execute the transaction itself. And if all of that is valid, the transaction will execute some piece of code on a target contract, like changing or sending tokens to another address or performing some sort of other action. Now, use cases for smart contract accounts. I'm just going to outline a few of the main use cases, but there's a lot of research going on in here, and there's a lot of interesting stuff happening. So the first one is multi-call. This is quite interesting because so far, up until now, actions on the blockchain have always been tied one-to-one with transactions. And that leads to a pretty bad UX sometimes, because, for example, to do something with an ERC20 token or allow a dApp to do something with your tokens, you first need to approve that dApp or allow that dApp to spend some of your tokens, and then on another transaction, trigger that dApp to use those tokens. And that means doing two transactions, one after the other. With multi-call, we can now bundle all actions into one single transaction, and that has many benefits. So one is UX. By bundling all those actions into one transaction, you can approve and call that dApp in a single transaction. You can also bundle a bunch of actions, for example, on a game or something like that, to execute or commit all those changes to the blockchain in a single transaction, saving the overhead of the transaction fees. And yeah, there's countless more examples of things that this could be used for. Then social recovery. This is something that we've been having on our wallets since pretty much the beginning. And what social recovery means is basically adding other roles to your account that are able to trigger some sort of recovery mechanism. In case you lose your key or your key is compromised, you could imagine that you have set your family members or your friends or an external service that acts as your guardian, as we call it. And by contacting them, they can trigger this recovery mechanism, and after a security period, in our case it's 7 days, you could then change the main signer of that account and in practice just recover access to your account. Of course, in the systems that we've put in place, this is done in a completely self-custodial way and can be cancelled at any time if your friends are not as good friends as you thought. Then fraud monitor, we also have systems in place in our wallets to, for example, allow an external service to sign all the transactions that you perform on your account. And that external service would, for example, process that transaction, understand it, and let you know whether or not it's considered fraudulent. So you could imagine that service having a blacklisted list of accounts or contracts that are known to be malicious. And since the account requires the signature of both the fraud monitor system and the main signer, you could imagine that fraud monitor system blocks that transaction. Of course, this is same way as we did with social recovery. This is all done in a self-custodial way and can be cancelled anytime as well. Now, with all of this, well, we have many more examples of what can be done on smart contract wallets, like, for example, way more efficient multisigs, or way better experience for games, or even better compatibility with different wallet systems. But yeah, these are just some of the examples of how UX could be solved thanks to smart contract wallets and account abstraction. Now, Argent is building a bunch of stuff on Starknet, and all of that is thanks to account abstraction and the fact that Starknet supports natively these smart contract accounts. We have our web wallet SDK, which is an SDK that pretty much allows all dApps to have an email and a password flow for their users, and that gives them a completely self-custodial wallet that has social recovery and this fraud monitor system, basically bringing the best of the Web2 experience to Web3, and this is all supported by account abstraction on Starknet. We also have our Argent mobile app, which is basically the most seamless experience that anyone could have on the blockchain, because it's a flow that doesn't require any management of seed phrases or keys, and of course it has the fraud monitor service and all that social recovery. And we also have Argent X, which is a browser extension wallet, more for tech-savvy users or people that are more experienced with blockchain technologies. It'll soon be supporting our Argent multisig for DAOs and institutions. And yeah, that's all built on Starknet. So some conclusions. Starknet is a validity rollup on Ethereum solving the scalability issue. Starknet is the only network today that supports only smart contract accounts, and that brings huge UX improvements to that network, because all the accounts are now enabled to have that advanced functionality. And that's why we choose to build on Starknet. Well, that's it for me. Thanks a lot. I'm, again, Ismael, product manager at Argent. We do smart contract wallets, and if you want to chat with me after the talk, I'll be around. Thanks.